How's it going, guys? Today I want to go over the Module 2 test. So let's go ahead and get started. So this question is asking which of the following shows the graph of g of x equals 2 times the absolute value of x plus 1 minus 3. Let me go ahead and just rewrite that. We want g of x to equal 2 times the absolute value of x plus 1 minus 3. So I'm going to go ahead and figure out what my vertex is. We know that from our h and our k. So our vertex is -1, -3. So I'm going to go to these answer choices and mark off what doesn't have the vertex -1, -3. A doesn't have a vertex of -1, -3. Neither does C, and neither does D. So that really just leaves answer choice B, and that's what our answer is. Number 2, we have which function, when graph is a reflection of the x-axis compared to f of x equals f of x. So to have a reflection over the x-axis, we want a negative to be outside of the absolute value signs, or we want it where the a is. So we want a negative a, in other words. And A doesn't have a negative A, C doesn't have a negative A, neither does D. So that leaves B to be our answer. For number 3, which function, when graph is a reflection of the y-axis compared to f of x equals absolute value of x? In this case, we want our negative to be with the B value. A doesn't have any negative value, so that's wrong. B has a negative at the A value, so that's wrong. And C has a negative value at the B. It's kind of hard to see, but this does say g of x equals the absolute value of -2/3 x plus 5 plus 2. And since our negative is with our b value, that makes our answer choice, or sorry, our answer for number 3 to be C. All right, number 4. We're asked which function, when graph is a translation right 6 units and up 7 units compared to f of x equals absolute value of x. So let's go ahead and just make what our function should be. So our g of x, we're told we want a translation right 6 units. So we want the absolute value of x minus 6. And we want to go up 7 units, so we want our k to be 7. So we want g of x equals the absolute value of x minus 6 plus 7, and that gives us answer choice D. For 5, we're given the transformation equation, g of x equals -8 times x plus 1 minus 5. Let me rewrite that just to make it a little more clear. -8 times the absolute value of x plus 1 minus 5. Which of the following shows the corresponding transformation rule? So let's go ahead and figure out what our transformation rule is anyway. Remember, it should be b of x plus h, comma, ay plus k. In this g of x we have here, our a value is -8, our b is 1, our h is -1, and our k is -5. So our transformation rule, let's do it right here on the side. It's b, which is 1, times our x, plus h, which is -1, comma a, which is -8, plus our k value, which is, or sorry, -8 times y first. So -8y. And we're going to add k to that. Our k is -5, so it's -8y minus 5. So our answer choice in this problem, sorry, our answer to number 5 should be C. All right, number 6, given the transformation equation, g of x equals 2 times the absolute value of 3 times x plus h, x plus 8 minus 7, which of the following shows a corresponding transformation rule? So let's go ahead and do the same thing again. Our g of x is 2 times the absolute value of 3 x plus 8 minus 7. So our a is 2, our b, remember that 3 is 1 over b, so our b is actually 1/3. Our h is -8, and our k is -7. So remember, we want bx plus h, comma ay plus k. So our b is 1/3, so 1/3 x, plus our h, which is -8, comma a, which is 2, times our y, plus our k, which is -7. All right, so that leaves us with answer choice A for this one, 1/3 x minus 8, comma 2y minus 7. For number 7, we're asked if an isolated absolute value expression is equal to a negative number, then the absolute value equation will have blank solutions. For example, 2x minus 12 equals -2. How many answer choices? How many answers will we have to this expression? In this case, it will be none, and that's because an absolute value turns everything to a positive number. So if we turn whatever's inside of that absolute value signs into a positive number, it will never be equal to -2, since a positive number will never equal a negative number. So for 7, the answer choice is no solutions. Number 8, we're asked to solve the following absolute value equations. We're asked to solve absolute value of 2x minus 7 equals -3. We're going to add 7 to both sides. Absolute value of 2x equals 4. From this case, we're going to have two different scenarios. We have when 2x equals a positive number, so 2x equals 4, and when 2x equals a negative number. Negative 2x, actually just rewrite that a little more properly. Negative 2x equals 4. And that's because the absolute value turns everything to a positive. So we have two scenarios when whatever's inside the absolute value sign is positive and when everything inside of it is negative. So we have to account for both scenarios. So to solve for x, in this case, we're just going to divide by 2. X equals 2. In this case, we're going to divide by -2. And we get x equals -2. So our answer choice for 8, our answer for 8 is going to be C. For number 9, we're asked to do the same thing. Solve the following absolute value equations. So -2 times x minus 6 plus 8 equals -2. First thing we're going to do is isolate the absolute value sign. So we're going to minus 8, -2, x minus 6 equals -10. Divide by -2. We get the absolute value of x minus 6 equals 5. So like we did last problem, we're going to account for both scenarios when x minus 6 is positive and when x minus 6 is negative. So x minus 6 equals 5, or when x minus 6 is negative. So solve for x. We'll add 6 to both sides for the left one. So x can equal 11. Here we're going to multiply by -1 first. So we get x minus 6 equals -5. Add 6 to both sides. X equals 1. So this problem here, x can equal 11 or x can equal 1. So that gives us an answer of D. Okay. Okay, so for number 10, what we're going to do here, a train's traveling 70 miles per hour. It's travels 900 miles from Houston to Albuquerque and then back to Houston. Which of the following equations represents the train's distance, d of t, from Houston at any time t during the trip? So our distance is going to equal the absolute value of how far we have to travel or how far each place is, minus how fast the train is going, multiplied by our time, or t. So in this case, our answer choice is, answer number 10 is D. 11, we're asked to solve the following absolute value equation. 3 times 4x minus 5 minus 2 equals 19. Same thing as before, we need to isolate the absolute value sign, add 2 to both sides. 3 times 4x minus 5 equals 21. Divide by 3 to both sides. Absolute value of 4x minus 5 equals 7. And like we said before, there's going to be 2 scenarios, 2 cases, when 4x minus 5 is positive. So 4x minus 5 equals 7. And when 4x minus 5 is negative. So let's go ahead and solve for x. Let's do the left side first. Add 5 to both sides. 4x equals 12. Divide by 4, x equals 3. For the left side, I'm going to multiply by -1 first to make the negative. So you get 4x minus 5 equals -7. Add 5 to both sides. 4x is supposed to be a 4. 4x equals -2, or x equals -1/2. So these are our 2 answer choices. X equals -1/2 and x equals 3. So let's go ahead and look at our answers. And we see our answer for this one should be A. X equals -1/2 or x equals 3. Okay, on to number 12. On number 12, we're told a laser is raised 5 centimeters up off a reflective table and pointed so that it hits the table 8 centimeters from the edge. The laser beam follows a path defined by the absolute value function. V of h equals 2/5 times h, the absolute value of h minus 8, where v is the vertical height and h is the horizontal position from the edge of the table. Use an absolute value model to find the horizontal positions where the laser is 2 centimeters from the table. So we're told to use this equation over here, and we need to figure out when the laser is 2 centimeters away from the table or up from the table, or in other words, when our y is 2. So our v of h, we solve that for when that equals 2. So we have 2. That's going to equal, that's very ugly, we rewrite that really quick. 2 equals 2/5 times h minus 8. Okay, so we have this problem over here, and now we're going to solve for our h. So we're going to multiply by 5/2 on both sides to get rid of that 2/5. So the 5's cancel, the 2's cancel, and here we get 5 times 2, which is 10, divided by 2. That equals absolute value of h minus 8. 10/2 is just 5. 5 equals absolute value of h minus 8. We have 2 scenarios. When h minus 8 is positive and when it's negative, so we have 5 equals positive h minus 8. And 5 equals negative h minus 8. Those are our 2 scenarios. Let's go ahead and solve for h. Let's add 8 to both sides. 13 equals h. We're going to divide by -1 first. -5 equals h minus 8. Add 8 to both sides. And we get 3 equals h. So h equals 3. Or h equals 13. And in this case, both answers make sense. Remember, when it comes to word problems, you have to double check that our answers actually make sense. And we can be 3 centimeters into the table and 13 centimeters into the table. That makes sense. If we had a negative h, that would not be our answer choice, or could it be a real answer choice since you can't be negative centimeters into a table. So what I'm trying to say is, when it comes to word problems, once you get your answers, double check that it actually makes sense. Okay? So in this case, this answer is C. H equals 3 and H equals 13. 13, if an isolated absolute value expression is equal to 0, then the absolute value equation will have blank solutions. So we're asked, how many solutions can we have if we have 2x plus 8 equals 0, for instance, when an isolated absolute value expression equals 0. In this case, we can only have 1. Since 0 is neither positive or negative, this will only happen when 2x plus 8 equals 0. It's the only time this will ever hold true, since we want the absolute value of 0. So that's the only thing that will equal 0. The absolute value of 0 is the only way you'll get an absolute values equation to equal 0. So in this case, we can only have one solution. 14, solve the absolute value equation. In this case, it's saying negative of x plus 1 minus 1 equals negative 3. We're asked to solve it graphically. So we have our graph over here, and our answer will be where these two graphs intersect. Right here and right here. And that's at negative 3, or sorry, x equals negative 3, and at x equals 1. Or letter choice D. For 15, when solving an absolute value inequality, if the absolute value expression is isolated, it is greater than a negative number, then the solution will be blank. For example, absolute value of x plus 11 is greater than negative 3. So we're asked, when does an isolated absolute value expression, when will it be greater than a negative number? In this case, it will be all real numbers. It will always be greater than a negative number, since every positive number is greater than every negative number. So in this case, this will be all real numbers. Uh, 16, solve the following absolute value inequality. It's already isolated for us, so we can go ahead and just make our two scenarios. So greater than 9. Let's go ahead and make our two scenarios. When 3x plus 6, sorry, is positive, and when it's negative. So 3x plus 6 is greater than 9, and when negative, 3x plus 6 is less than 9. Those are our two scenarios. Let's go ahead and solve it. We're going to minus 6 to both sides. 3x is greater than 3, or x is greater than 1. We're going to, for the right side now, we're going to divide by negative 1. And when you divide or multiply by a negative number, remember, you get to flip the sign. So we end up getting 3x plus 6 is greater than 9, minus 6. 3x is, oh, sorry, it's supposed to be negative 9, because we multiply by a negative number. So it's 3x plus 6 is greater than negative 9. Sorry about that. Minus 6, minus 6. 3x is greater than negative 15, or x is greater than negative 5. Okay? Or, I'm not sure I got greater from, I'm completely losing my mind. It should be back up and redo this part right here, because I messed up in the very beginning. So it's negative, it's 3x plus 6, the negative version of that has to be greater than 9. We're going to multiply both sides by a negative number, or by a negative 1, sorry. And when we divide or multiply by a negative number, you flip the sign, so you get 3x plus 6 is less than negative 9 now. There we go. Minus 6 to both sides. 3x is less than negative 15. Divide by 3 on both sides. X is less than negative 5. There we go. Sorry about that. That's what we have. X is less than negative 5, or x is greater than 1. These don't overlap on a number line, so it has to be or in between it. So we want when x is greater than 1, or when x is less than negative 5. So in this case, our answer is D. All right, number 17, we're going to do the same thing. We're solving an absolute value inequality. Let's hope I don't mess up this time. And the absolute value is isolated already, so we can go ahead and set up our two scenarios. When 2x plus 7 is positive, and when it's negative. So we have 2x plus 7 is greater than 15. Not off to a good start. That's greater than 15, and negative 2x plus 7 is greater than 15. So let's go ahead and solve the positive side first, the left side. So minus 7, 2x is greater than 8. Divide by 2. X is greater than 4. For the left side, we're going to divide or multiply by -1, whatever you want to say. So we get 2x plus 7 is less than -15, minus 7, minus 7. 2x is less than -22, or x is less than -11. So we have x has to be less than -11, or x is greater than 4. These don't overlap, so we have an or in between both solutions. So x is less than -11, or x is greater than 4. Our answer is A. All right, for 18, we're told to solve the following absolute value inequality. In this case, the absolute value sign is not isolated, so we're going to isolate it, and then we'll set up our two scenarios. So let's actually rewrite the equation to make sure you can see it. I know it's a little blurry. So we have 3 times x minus 2 plus 13 is less than 1, minus 13 on both sides. 3 times absolute value of x minus 2 is less than -12. Divide by 3, divide by 3. Absolute value of x minus 2 is less than -4. So we have we have our isolated absolute value expression. So from here, let's go ahead and set up our two scenarios. I'm going to move this a little more to the middle. So we have absolute value of x minus 2 is less than -4. We have two scenarios, when x minus 2 is positive and when it's negative. So x minus 2 is less than -4, and when negative of x minus 2 is less than -4. So I'm going to add 2 to both sides. For the left side first, the positive side, add 2 to both sides. X is less than -2. That's one answer choice. And for the right side, we're going to multiply by -1. You get x minus 2. And remember, we multiply or divide by a negative number. You have to flip the sign. So that's greater than 4. Add 2. Add 2. X is greater than 6. So we have x is greater than 6, or x is less than -2. All right, so we solved it out, and this is what we would get, but remember we have to check for extraneous solutions. So what we're going to do is we're going to pick an answer choice to both sides and see if it makes sense. So we have x is less than -2, so let's use x equals -3. And let's go back to the original problem and see if it makes sense. So our original problem is 3 times x minus 2 plus 13 is less than 1. So let's make sure that x is less than -2 actually makes sense. So I'm going to use x equals -3 and see what happens. So that's 3 times -3 minus 2 plus 13 is less than 1. -3 minus 2 is -5. The absolute value of -5 is +5. So 3 times 5 plus 13 has to be less than 1. 3 times 5 is 15, plus 13 is less than 1. 28 is less than 1. That doesn't make any sense, right? 28 is not smaller than 1. So we can go back to our two answer choices, and we can cross this one out since it doesn't make any sense. So anytime x is less than -2, that actually doesn't work. We can cross that out. So now let's check x is greater than 6 and see if that makes any sense. So x is greater than 6. I'm going to use 7, and we're going to use the same equation. 3 times x minus 2. I'm going to use 7 plus 13 is less than 1. Let's go ahead and see if this makes sense. Minus 13 to both sides. 3 times the absolute value of 7 minus 2, which is 5, is less than that's -12. Don't know why that took me so long to figure out. So we have 15 is less than -12. That doesn't make any sense either. So we can go back and we can cross out x is greater than 6 as well. That doesn't make any sense. So in this case, both our solutions that we found didn't make any sense. And we actually could have done it from right here. At this point right here, we could have stopped and we could have realized that we don't have to go any further since this doesn't make any sense. We can never have an absolute value less than a negative number. So when we got to this point right here, the absolute value of x minus 2 is less than negative 4. We could have stopped and said, this doesn't make any sense. We can never have an absolute value expression to be less than a negative number. So in this problem here, our answer is no solutions. That's because when we double checked our solutions that we did get, they didn't make any sense. And at the same time, when we're solving it, we got to the absolute value of x minus 2 is less than negative 4. That doesn't make any sense. An absolute value, an isolated absolute value expression can never be less than a negative number. So we can say this problem has no solutions. All right, number 19, solve the following absolute value inequality using the graph. We have the function 2 times absolute value of x plus 1 minus 2 is greater than 2. So we want the absolute value expression, 2 times absolute value x plus 1 minus 2 to be greater than 2. Or in other words, we want all the values right here where the graph is greater than that line y equals 2. Everything above this green line is our answer choice. So we see we intersect at x equals 1 right here, and over here at x equals negative 3. So you want all the x values less than that point right there. So you want all the x values less than negative 3, and all the x values greater than 1. And since they're not connected, it's going to be connected with an or. So you want x is less than negative 3, or x is greater than 1, or C. For 20, we're asked to solve the following absolute value inequalities using a given graph. We have negative 2, x plus 3 is greater than negative 1. And we gave you the graph over here, so you can use the graph to solve it. So what we want is all the values of the graph greater than negative 1, everything above this line right here. Okay? So we want the red portion I'm going to draw right here. That is where our answer is. And our intersections of the two lines, of the two graphs, are these right here. So we want everything to the right of x equals negative 5. I'm not sure why I would put 15. But everything to the left of x equals negative 5, and everything to the left of x equals negative 1. So we want x is greater than negative 5, and x is less than negative 1. It's a compound inequality since we only have one portion of the graph as our answer choice. So we want x to be less than negative 1 and greater than negative 5. That's what our answer should be. Or in other words, our answer choice for this problem is B.